something is waiting for us at the edge of the solar system. A wall, and according to every model we had, it shouldn't be there. For decades, astronomers thought they knew what the boundary of our solar system looked like. They built simulations. They ran calculations. They predicted that the sun's influence would stretch out about twice as far as we now know it actually reaches. Then in 2012, a 40-year-old spacecraft named Voyager 1 punched through that boundary and found something that broke all of our models. This is the story of the wall at the edge of the solar system, and what it taught us about how little we really know. To understand why the wall is such a problem, you first need to understand what the sun does. Every second, our star fires about 1 million tons of charged particles into space at over 1 million miles per hour. This is the solar wind, and it streams outward in all directions, past all the planets, past Pluto, far beyond anything we could call the solar system. But it doesn't go forever. At some point, the solar wind meets the interstellar medium, the thin soup of gas and dust that fills the space between stars. And when those two forces collide, something remarkable happens. A shock wave, a boundary, a wall. Astronomers called it the heliopause. It's the place where the sun's influence ends and the rest of the galaxy begins. Now here's where the detective story gets interesting. When we modeled where this wall should be, we assumed certain things about the interstellar medium. We assumed it was relatively dense. We assumed it was moving at a certain speed. We built our predictions around those assumptions. Voyager 1 found something different. On August 25, 2012, at a distance of about 121 astronomical units from the Sun, that's over 11 billion miles, Voyager 1 crossed the heliopause, and the instruments went crazy. The spacecraft detected a sudden, dramatic change in the particles around it. The number of particles coming from the Sun dropped to nearly zero. Meanwhile, the number of cosmic rays from deep space increased by a factor of 40. But that wasn't the surprising part. The surprising part was how close the wall was. Our model said it should be out there at around 150, maybe 170 astronomical units. Voyager found it at 121. That's not a small discrepancy. That's a fundamental failure of our understanding. And it gets stranger. When Voyager 2 crossed the heliopause in November 2018, it confirmed the finding. The wall was closer than expected, but it also found something Voyager 1 missed. Something that suggested our entire picture of the boundary might be wrong. Voyager 2 detected what scientists call the magnetic highway. The magnetic field at the edge of the solar system, it turns out, is aligned with the galactic magnetic field. No one predicted this. The models assumed the two fields would be perpendicular, opposing each other, creating a complex and turbulent barrier. Instead, they seemed to flow together, like two rivers joining, and we had no idea. There's also the hydrogen wall. Before Voyager reached the heliopause, astronomers predicted that the boundary would be preceded by a dense cloud of interstellar hydrogen. A literal wall of gas piled up where the solar wind meets the interstellar medium. The New Horizons spacecraft, on its way to Pluto and beyond, confirmed that this hydrogen wall exists. We detected it. It's real. But we still don't fully understand what role it plays. Is it part of the boundary? A separate feature? A sign of something even stranger happening at the edge? And then there's the shape problem. For years, we thought the Heliosphere looked like a comet. A round head with a long tail streaming behind as the sun moved through the galaxy. New data from the Interstellar Boundary Explorer, IBEX, showed something else entirely. The boundary isn't comet-shaped. It looks more like a four-leaf clover, with long ribbons of energetic neutral atoms extending in unexpected directions. No model predicted this. No one can fully explain it. So where does that leave us? We built the most advanced instruments ever created. We launched them 45 years ago. They crossed the termination shock, traveled through the heliosheath, that turbulent region where the solar wind slows and twists, and finally broke through into interstellar space. And what they found there was not what we expected. The wall was in the wrong place. The magnetic fields aligned in ways we didn't predict. The shape of our own solar system's bubble remains a mystery. And somewhere beyond the heliopause, Voyager 1 and Voyager 2 continue to send back data, still teaching us things about the neighborhood we thought we understood. Maybe the most important lesson isn't what we found at the edge of the solar system. Maybe it's this. Even with all our instruments, all our calculations, all our best guesses, the universe still knows how to surprise us. And somewhere out there, past the wall, past the heliopause, past everything the sun has ever touched, the galaxy continues, unmapped, unpredicted, waiting. If that's what we know, imagine what we don't. Drop your theory about what's really happening at that boundary. What do you think is out there, past the wall? And if you want more of this, you know where the button is. Keep drifting.